It's a recording. Oh, we don't want the magnets, right? Yeah, we'll see later what it picks up. All right. Any questions up to here? Significant figures. Sometimes referred to as significant digits. Non-zero numbers are significant. So when dealing with significant digits, you need to be able to identify how many digits in a number are significant. So 451, how many significant digits? 3. All right. Unison would have been really cool just then. Try that again. How many significant digits? That was much better. All right. Now, 0 is always the bugger on this one. So, any number between significant digits are or is significant. So, since the non-zero numbers are significant, if I have a 0 in between, that 0 is significant because it's between two other numbers that are significant. So, how many significant figures?
5.
Do it in rounds. All right. It's the physics equivalent of row, row, row your boat. Leading zeros, not significant. So you're cruising along, you eventually hit a non-zero number. Any of the zeros in front of that, I don't really care as far as significance goes. They have a bearing in terms of units and neat jump like that. But if I stick some zeros up front here, that doesn't do anything to change the precision of the number or the number itself. Mainly the precision of it. So 0.00012078, leading zeros, because they come in front of the first non-zero. So those are not significant. This is still 5 significant figures. Let's throw a mix in there. Let's hold off on that one for now. Number of significant figures? All right, we're on a roll. Let me smear it now. The trailing zeros. Trailing zeros to the left of decimal, not significant, unless it's between others that are significant. So 1, 2, 4, 7, 8, 0, 0, 0. These are trailing zeros. They're to the left of the decimal. Even though a decimal is not written here, it's implied there's a decimal point right here. So these zeros are not significant. This is still 5 significant figures. find markers that are dark enough for me. Now, if you're to the right of them, I think in essence it comes down to, I have two numbers here. In math class, are they equal?
Yes.
At least the math I was taught. So some of you agree with me. Some of you are just giving me stares. I'm not quite sure what you were taught. However, in science, do they mean the same thing? All right. I don't know if you were just anticipating that it was going to be the opposite answer or whether you have a convincing argument. So why do they not mean the same thing? What is the difference in meaning?
Isn't one more accurate than the other?
Which one's more accurate?
The 0.0.
Okay. This is, so in science, there are some exact numbers that we deal with, but a lot of the numbers, especially in lab class, we are going to be doing measurements and we have to do it to a certain level of precision. If I measured the length of this table and I said the length of the table was 10.0 meters, well, one, that'd be a bad measurement, but let's just pretend it's right. 10.0 meters, I'm not claiming that it is exactly 10.0 meters. All I'm saying is that I rounded off to the 10th place. Whereas this one, I rounded off to the 10th place. So, trailing zeros to the right of the decimal matter. So, trailing zeros to right of decimal. Significant. Because it's saying you did that much extra effort to get it down to that much finer detail. Because the farther you go to the right, the greater the detail is. How many significant digits?
5.
I got a 5 over there.
4. 3.
All right, we got 5, 4. Anyone else?
3.
5, 4, 3. We're on a roll. Anyone go for 2? So we're just going 5, 4, and 3. All right, so let's just do. See if science by democracy works. How many say 5? All right, sorry, before we keep going on this one, have an opinion. Even if it's just pure guess, because you've never seen this stuff before, it's completely brand new to you, whatever it is, if you've got a gut feeling, go with that. If you know, go with that, especially if you know that, if you know the answer. But if you don't know, just pick one. So there should be 10 votes total here, assuming I can count. And apparently I can today. All right, so who says 5? Change your mind?
Yeah, I changed it to 3.
All right, who says 4? 1, 2. Who says 3? All right, everyone voted. All right, so let's take a look at the rules there. Non-significant, non-zeros are significant, so there's at least 2. Those are significant. Any number between significant digits are significant. Well, we don't have any that showing up yet. Leading zeros are not significant, so those are not significant. Trailing zeros to the left of the decimal. Well, there are no trailing zeros to the left of the decimals. Trailing zeros to the right of the decimal are significant. It is indeed 3. Democracy works. But I think you'll find at various points in the class I will do something similar, and it doesn't always work. All right, so let's do O, let's throw a number up front. How many significant numbers now? So there's a vote for 10. Anyone have a different number?
8.
Any other candidates? Let's try again and see if we can vote the truth. 8. Who says 8? Way to stand alone. 10. I'm assuming it's 9. All right. So if that's significant, those are significant, and that's significant because they're non-zero. These are significant because they're between significant numbers. And then trailing zeros to the right of the decimal are significant, so it is indeed all of them. Which two were you excluding, these two or those two?
Those 2 right there for the decimal.
Yeah, that's the rule there. All right, I assume we're all experts on this, that anybody could ask you a question and you're good to go on number of significant digits. And if not, then if this is your only weak point, more power to you. All right, questions to hear before we talk about the rules of addition, subtraction, multiplication, division with significant digits. All right, so addition and subtraction have the same basic rule in terms of significant digits. You're looking at level of precision. For instance, how many people roughly go to Forsyth Tech? Just give me a number.
1,000.
1,000?
1,000.
All right. And then one more person comes to the school. Would that change your answer?
1,001.
So this is exactly 1,000 you're claiming? I know I said just throw me a number, but when you said 1,000, were you thinking it's somewhere around 1,000, or are you thinking it's exactly 1,000?
Somewhere around 1,000.
Yeah, so if I add one more, is that gonna change? So when you're dealing with addition and subtraction and significant digits, you wanna care about the precision. This has one significant digit. It's rounded off based upon what Amy was saying afterwards. So adding one more, yeah, mathematically they tell you it's 1,001, but considering this is to the nearest thousands place, this is to the nearest thousands place. And so if you care about significant digits, probably not the right word about whether you care or not. If you have to take them into account, the final answer would be 1,000. I'm just picturing an elementary school kid doing 1,000 plus 1. They go, no, it's 1,000. You forgot significant digits. So if I have 54.37 plus 2.16059, I add it straight up just the way they taught us in math class. 5903, carry the 1, 5 decimal point 65. You do the math like normally. Like normal. Significant digits is about presentation of answer. So now we bring it in. If I'm now to present the answer, I now look at the level of precision. This goes out to the 100,000th place. This goes out to the 100th place. This is greater precision, but it's the weakest link which drives it. We need to round it off to that spot right there. That would be the final answer with significant digits. significant digits, taking significant digits into account, what is the answer?
Is it -1?
Not -1. Good. Having trouble seeing it from that angle, perhaps?
So it's 50?
No, not 50.
44.
And then,
0.0.
all right, so we have these two. Let's take a look at it. This is rounded off to what place? Does the language change that much? The decimal point, this is a ones place, tens place, hundreds place, tenths, hundredths, thousandths. Is this strange vocabulary? I'm getting some people shaking their heads no. I'm trying to get a read here. Every class is different, so I'm trying to figure out what people do and do not know.
Is it 44.0?
All right, so this is to what place? All right, so it's to the tens place. This is to what place? Ones. All right, so we subtract, we get 44 as was said, but we go to the least precise value. That's in the nearest tens place, and so therefore we round this off to the nearest tens place, so 40 is the final answer. Now, to me, I look at that and I'm going, that just sort of grades. 50 minus 6 is 44, it's not 40. It comes down to the meaning behind it. If this is just a math class, yes, it's 44. But again, in science, we're dealing with a lot of measurements here. This 50 is, well, the way it's presented here, this represents some number between 45 and 55. This 6 right here represents some number between 5.5 and 6.5. Right. So there are questions up to here before I talk about the borderline cases. Suppose that 50 there were actually represented 50. They did measurements out. It's not between 45 and 55, but between 49 and a half and 59 and a half. Sorry, try that again. Between 49 and a half and 50 and a half. How do we indicate that that 0 actually is significant? Well, there are a couple ways of doing it. I can put a decimal point there indicating I actually did round it off to the nearest 1. I could also do 50 with a bar over the 0 indicating that it's significant. But that might look like that 0 repeats. Generally to the left of the decimal, it doesn't mean that. Or 50 with the 0 underlined. All these ways would indicate this is actually, we're going for 50. So these would represent a range from 49.5 to 50.5. It's more precise than this number here. And then rounding, so we'll take the 50 to the nearest tens place and subtract 5 from it. I'll do the math for you. 45. But then we have to go to the tens place because of the lack of precision in the first measurement. So when we take this to the tens place, is this 40 or 50? So we had a vote over there for 40. Let's try this democracy thing again. Who says 40? 1, 2. Who says 50? I think that was everyone else. All right. So there were 2 who said 40. What was your reasoning?
It's to the 10th place, right?
Sorry, louder.
It's to the 10th place, right?
It is to the nearest tens place, yes.
So you got to round down, I guess.
Do you always round down? Is that the rule you're going by?
Usually I round up and go to 50, but with this, he said round down.
Okay. And,
I just thought so.
okay. Excel rounds up. That if you got the 0.5 and you say only display a certain number of decimal places, Excel will always round up. Mathematically, you should round up half the time and round down half the time. So the rule is either you always round to the even or you always round to the odd. One or the other. So you've got three different systems here. Round to the even, in which case it would be 40. Round to the odd, in which case it would be 50. Or always round up, because Excel, life dictated to by Microsoft, they always round up, they round up to 50. What do you do? Pick one, live with it. Usually, it's hard to tell. There are not a lot of numbers that end exactly in 5 that you're rounding one way or the other. Usually it's, you end up with 0.49777, which you would round down on, or 0.5001, in case you'd round up. But sometimes it does turn out where you end up with a 0.5 exactly, or a 0.005, or whatever, you end up with a 5 there, and you have to round one way or the other, and you decide. And usually I can't tell, looking at your work, which way it's supposed to go, but there are occasions in which, they rounded this one down to the even, they rounded this one down to the odd. All right, so they didn't pick one of the 3 methods that were prescribed there. So, rule of thumb, pick a method, go with it. Questions to hear? All right, multiplication division, that's a lot simpler in my mind. Can somebody actually do this? I have a calculator out. It is helpful to have several people with calculators, because often I will go, and this is, and assume somebody's going to do it on a calculator.
17 million.
So 13 million?
Oh, 17.
7.
112. 460. No. That's it.
That get it all?
Yes.
Okay.
I got the same thing.
All right, excellent. Now there was, I have done problems where I've done the math over here. This was, it was a 251 class. I've done the math over here, and I did one of these. Hey, what's the answer to this? Somebody told me the answer. Generally, there's a pause to see if anyone else says anything. Someone else goes, hey, I got that too. And then I went ahead and did the whole thing. I came out with an answer that I knew was wrong, and I go, wow. And I'm sitting here looking at it, trying to figure out what I did wrong, and someone said, oh, that problem, that over there, that's not the right answer. So if there's a mistake on the board, point it out sooner than later. I have had it also where the first 3 people to speak up with an answer actually gave me the wrong answer. They made the exact same mistake. And someone else was sitting there quietly. So if you get a different answer, just please speak up. All right, so significance. How many significant figures?
5.
Yeah, 5. Those are all significant, and then that is between 2 significants. How many significant figures here? I heard 2 and 3. And it's not 2.5. Trailing 0 to the left of the decimal.
Are significant.
Or not.
Also 2.
So it is indeed 2. Jacob, you said are significant? To the left of, trailing zeros to the left of the decimal are not, and possibly, it might be shocking, but my handwriting might have been so sloppy that you missed the word not.
I wrote down trailing zeros to the right of the decimal is significant.
Yes, that is true.
Oh, okay, never mind.
So we got left, right, backwards?
Yeah.
Ah. Now, This has 5 significant digits, this has 2 significant digits, therefore this has the least of those 2 numbers, so it has 2. So the final answer in presentation form, 17000. And again, after the first lab, you don't need to worry about it, but for the first lab you do. Yeah, but there's more of the same. There's some videos that I've posted that under coursework, chapter 1, where I do some other examples, and pretty much the same explanation. Questions before I erase this? And it's gone forever. So it'll still be here and recorded, but other than that. That's supposed to be a rectangle. What's the formula for the area of a rectangle?
Width times length.
Okay. You went width first? All right. Which one's the width, which one's the length?
The width is, the bottom and top line.
And that's length?
Yes,
Why?
it's just how I learned it.
Okay. You could also say, because I said so.
Yeah.
It doesn't matter. One of them's width and one of them's length. Pick one. Stick with it. Apparently you're sticking with this as the width here. Let's make this 5 meters and this 4 meters. So what's the area?
20 meters squared.
So, units. Even though this does satisfy significant digits here, I'm not worrying about significant digits for this next part. So we do 4 meters times 5 meters, or 5 meters times 4 meters, whichever way you're dealing with it. That's the math problem right there, 4 times 5, 20. But the meters here, it's what separates us from the math people. Yeah, well, it depends on who your math teacher is, I guess. If you just write 20 as your answer, the area is 20, I'm gonna dock you for that one. Units matter. So in terms of the units here, I have meters times meters. You treat them just like you would anything that you're multiplying. So I have 20 times meters. Well, anything times itself is squared, so this is 20 square meters. Typically, you don't put the dot between the number and the first unit there, but it's not officially wrong. So I have a circle here, and I measure around it, and I say that the circumference is 22 centimeters, and I say that the diameter is 7 centimeters. Again, not worried about sig fig right now. So if I divide circumference by diameter, all right, before anyone blurts out an answer here, I want you to think about what the units will be in the final answer. All right, so let's just deal with the calculator piece of it. 22 divided by 7. We could do a decimal form on it, and Amy's about to tell me what that is, or we could just leave it as an improper fraction.
It's 3.142.
142.
Or do you want me to keep going?
It's going to be 3.142.
8.5.
Yeah, so if you were, all right, so let's talk about 3.142 versus 142.8 versus 3.142, 143. The next digit after this is 8. On a quiz or test, fine, I wouldn't dock you for a 3.142. On labs, yes, you'll have a week to actually do the labs, go through the calculations, I do expect you to round properly. So on a lab, you better write this one instead of that, or you could just take it out though, you don't have to round up anymore, which some people do. Some people pull out their calculator and they'll write 10 digits down, sure. On the lab, I will grade you out to whatever digit you take it. All right, so stick with the 3.143 and units.
Wouldn't it be just C over D? Wouldn't it be just C over D?
No, those are not units.
Oh, okay.
Centimeter squared. Centimeter squared.
Nope, not quite. Centimeters squared would be centimeters times centimeters. What's the math operation we're doing here?
Division.
It's centimeters divided by centimeters. So what should I write over here?
Centimeters.
Ooh, nope. And by the way, there's a penalty for wrong units, but it's not as big as a penalty for no units, unless there shouldn't be any units. So we've eliminated it's not centimeters squared. Any other proposals for what units we should write?
Millimeters?
No.
Square root of centimeters?
No.
Thought that was wrong, that's a shot.
I think some of you know the answer, but are afraid to say it.
Is it 1/2 centimeters? 1/2 centimeters?
No. You said 1/2? Yeah. Okay, all right, so think about over here. We had meters times meters because I'm doing multiplication here. Here I'm doing division, so I have,
Would it be over centimeters?
upper centimeters?
What, over centimeters? Is this division?
Oh, this over centimeters?
Yeah.
No. What happened to the other centimeter?
Do they cancel out?
Yes. So you could have actually just gone straight with that and done centimeters per centimeter. But anything divided by itself is 1. At least that's what the math people tell me. Other than 0. Despite what my son's second grade English or math teacher said.